Okay, hi folks. This is the third and final salt prep video. And in this one, we're going to do how to make a soluble salt, again, but this time from an acid and an alkali. So, soluble tells you, just like the last video, that your salt is going to be aqueous. And we're going to make it from an acid, but this time, we're also going to make it from a alkali. And if you remember from the beginning of the topic, an alkali is a soluble base, which means your reactants are going to be an acid, aqueous, an alkali, also aqueous, making salt plus water. So what you should notice here for the first time is we don't have a solid. And because there's no excess solid reactant and there's no solid product, you're not going to be able to use filtering. There's no way to separate the soluble salt from either of the soluble reactants. So our only choice here is going to involve some new equipment that you haven't seen before. All right, so let's get to our example. The one we would have done if we had been in school would be the preparation of sodium chloride. Nice simple table salt. So let's go ahead and do that one. The acid you need, this time we're making a chloride in our salt. So the acid you need would be hydrochloric acid. HCl. And to get sodium, your alkali has to be sodium hydroxide. And these would both be solutions. Side product, water. All right, that's a nice easy one. That equation is already balanced for us. So we can jump right into the method for how to prepare pure dry sample of sodium chloride crystals. All right, so step one. We need to mix our acid and alkali, just like we've done in all the previous methods. But we need a more accurate tool because we need to measure exactly how much alkali it takes to perfectly neutralize the acid so that we have no leftover reactants. And the piece of equipment you're going to use is called a burette. You'll see in the video after this one, when you watch someone actually do this experiment, you'll see what a burette looks like. But it's a tall, thin tube of glass with very accurate readings on the side. This is more accurate than a measuring cylinder. They usually go to about 0.05 of a centimeter cubed. So very accurate. It has a tap at the bottom. That's the other important aspect of a burette, so that you can control the flow of solution from your burette. And actually, as you get close to where you want, you can even control it by turning the tap and it will come out drop by drop. So that's your equipment you're going to use. And we'll use that to add our base, or our alkali sodium hydroxide, to the acid. Now in your booklet, I've done the experiment so that we add acid to alkali, because I don't like when you have NaOH in the burette and students don't clean it properly, the burette can get clogged. So I'm going to do it that way on here. It actually doesn't matter which you put in. So we're going to start with HCl in our burette and NaOH down here in the reaction vessel, which is just going to be a conical flask. Okay, so here's my goal. I have NaOH, I'm going to add HCl. How will I know when it's complete? NaOH is colorless, HCl is colorless. Well, I need to add something that can change color when all the NaOH has been neutralized. And hopefully in your heads you're all saying, oh, an indicator. The answer is yes, we add an indicator. Okay. You're responsible for knowing what color your indicator will change based on which one you pick. So for this one, if I had picked phenolphthalein, it's starting alkali, so it would start pink, and when it's neutralized by the acid, it would go colorless. If I had chosen methyl orange, it would start yellow in the alkali, and once enough acid has been added and you had a bit of excess acid, it would turn red. So if you're asked that on an exam, be prepared to say the indicator is methyl orange, so the color change would be yellow to red. Okay. So our steps here would be add acid from burette until the color changes. Okay. And importantly, you need to note the volume. And the reason you need to note the volume is we have a problem. Say we've perfectly neutralized our NaOH, so great, we've got no leftover acid and alkali, but we've just contaminated it. Our sample's not pure because we've added all of this indicator to tell us when the base was neutralized. So once we've done this whole wonderful reaction, we need to do the whole thing again. You need to get your burette out again, put your HCl in your burette, rinse and dry your conical flask, put the exact same amount of NaOH into the conical flask, and repeat the whole process. Okay. This time, adding the same volume without indicator, to make sure your final solution is pure. All right, so this is going to give you a conical flask filled with only NaCl and water. Because it's a solution. So you shouldn't have any leftover reactants, and the products, as you can see, are just salt and water. So now it's pretty easy. It's exactly what you did in the last experiment. You simply need to get rid of the water. In this one, I tend to just get an evaporating basin, leave it in a warm place to dry. Get some nice cubic salt crystals, and all the water evaporates. In theory, you could do the crystallization method that we did in the second video, but for NaCl I usually don't bother. You get really nice crystals this way, and crystallizing NaCl by making it a saturated solution is really challenging, so we don't usually use that method. But that's it. This is how you make a soluble salt from two solutions, an acid and an alkali.